Good morning, everyone. My name is Reed Hall, and I'll be starting things off today. On behalf of our group, we are proud to present to you our senior design project, DigiNote. This project aimed to redefine how traditional field notes are created, stored, and accessed by developing an innovative digital field note application. After spending a few summers working in the survey industry, both in construction and legal surveying, we realized that the current means of preparing field notes with a pencil and paper was outdated and largely inefficient. Many other industries, including the survey industry, have all adopted some form of a digital standard for communicating, sharing, and storing information. Field notes vary from author to author, company to company, and this is largely a result of personal styles, the type of work being performed, expectations that have been laid out, and experience in creating field notes. Similarly, the physical design of a field note brings up another problem. Having a physical object that needs to be stored long-term not only takes up valuable space, but it must also be organized in a meaningful manner. This requires time, space, and at the end of the day, more money. Now, before we get too far ahead, let's take a look at what exactly field notes are, explain their uses, and analyze their key features. Field notes are used to explain the methods undertaken in a survey and record any extra data that would otherwise be difficult to explain through other methods of data collection, such as coordinates obtained with a total station. After the field data has been collected, it is essential for a draftsperson or surveyor to review the field notes to not only comprehend what the cluster of data points should end up looking like, but also troubleshoot any errors with the methods used during the survey or mend any mislabeled data. The picture to the right is an example of a field note prepared while undertaking a static GNSS survey. We see the recorded heights, data collection start and stop times, and a rough positioning of the rovers with respect to the job location. Another surveyor or draftsperson can quickly pick up this note and familiarize themselves with the geographic area and check that the data on screen is relatively the same as to what is illustrated. A key feature of field notes is the title and footer blocks. The title block contains important information such as the field crew who undertook the survey, the date, location, and weather. The middle of the field note is typically the area where any illustrations, computations, or any other pertinent job-related information is noted. The note to the right features computations from a leveling survey. Light grid lines on the field note paper allow the author to position the information systematically. As highlighted in the red box, a simple computation is performed by hand to ensure that the loop is closed within the desired accuracy. With regards to the methods of how a survey is carried out and documented, this field note serves as an excellent example. As you can imagine, plotting the data points on a screen would be quite confusing for a job of this nature. However, with simple illustrations, the data can become much easier to understand. The dashed line, highlighted by the red line, shows the traversing path that was used. While on the last station, point 4, we can see that 2 monuments were set along the property boundaries. Survey monuments that have been set are typically represented by a hollow square. Filled-in squares, such as highlighted here, denote survey monuments that have been found. This further enables a reader to quickly distinguish between monuments that have been set versus found. A quick sentence is jotted down at the top to describe the coordinate system, if any, that the data is in. Comparisons of distance and measurements, distances measured, and measurements from previous surveys can quickly be shown on the field notes. Lastly, the plans referenced to conduct this survey can be listed, allowing other surveyors or draftspersons to quickly review previous survey plans. All of these features and highlights are aspects that a digital field note application should be capable of at the bare minimum. Now, field notes are the only record of a field survey actually taking place. When discussing disputed boundaries in court, the Association of Canadian Land Surveyors provides a hierarchy of evidence that is supported by previous court judgments. The fourth and final level of evidence considered are measurements quoted by the original survey on a plan or in field notes. Although this evidence can easily be outranked by natural boundaries or original monuments, it nevertheless demonstrates the legal purpose that field notes serve. In the event of a boundary dispute, with no other evidence, original field notes can be consulted. And this still rings true even if there are natural boundaries or original monuments the evidence from field notes might still be considered. For field notes to be admissible in the court of law, they must be authentic and recorded during the time of survey. Any erase marks or mislabeled dates could render the field notes inadmissible. It is our duty to ensure that digital field notes can fall in line with paper field notes and maintain the same integrity.
So when we talk about problems in the current field note method, there's first and foremost a lack of efficiency. Even though the size of content in a survey note is variable, the time it takes to record this info needs to adapt some form of consistency, a measure that would output similar time results for similar project needs. And part of that stems into the authoring of field notes, the idea that every surveyor has some unique writing or drawing aspect that might be faster, slower, messier, neat, detailed, or simplified. Whatever it may be, it's hard to find any resemblance in note-taking, and that's mostly where the limitation exists. Although there is also factors in storage. Specifically, survey industries might see thousands of physically documented notes in a year, and these can quickly fill up filing cabinets, let alone a storage room, until the point where notes get mixed up or even worse, misplaced. And so this stems into durability, the idea that the current method is subject to all forms of damage, from rips and tears to wet weather, and even the odd case of office fire. The matter of the fact is that a paper-only policy is greatly vulnerable in preserving its integrity. And that idea of supply kind of attaches to the end of this, in that the constant requirement for this one-to-one ratio of field books is taking away funds that could be utilized elsewhere. So these are the missing efficiencies in an ongoing expansive industry. So what should we be targeting specifically to account for these limitations? Well, rapid data entry is of obvious importance. Having some workflow in a digital setting creates a process, one that can be systematically followed with little to no variation of the collected data. In this process, we want to reduce the errors mostly caused by ourselves as humans. Specifically, a digital field note should be able to do the calculations or adjust a sketch to fit all surveys and to provide users their data on a mistake-free basis. We also mentioned storage and durability concerns, which is something a computerized system can address in preserving and securing field notes. Building a platform to illustrate and store survey data is an upgrade from this tangible liability that is a field book to this virtual asset that can be a digital note taker. And this kind of links back to that central idea of uniformity, that by taking something that is produced in variety and converting it into a regularity would preserve the fundamental aspects of notes while giving it a more user-friendly design. So before we get into our design concept, it's important to show our process that ultimately led to our current product. Our initial stage started in a prototyping website called proto.io that essentially gave us the transition through the app without any interconnected functionality. This was the purest form of a layout with all the intended app features that we needed. So we used this to transition into mobile programming interfaces, such as Android SDK, which is an extension tool that bridges computer programs to Android platforms with limited access to embedded functionalities and outputs. This stage helped understand how the app might conform in multiple operating systems and give us considerations for program settings like the code language or the primary app system we might use, like Microsoft, Apple, or Android. Lastly, the Bubble.io platform was another mobile interface to help visualize the needed added features without relying on any source code, which is essentially hard-coded by line. And so taking all of these ideas from all stages gave us our foundation for implementing the latest design in a more familiar coding environment to us as engineers, which the next set of slides will show.
So that was a walkthrough of the design process, and I'm going to follow up by showing what the next big leap for us was in terms of taking this idea and transforming it into a tangible and commercially viable product. In the end, we decided to present our solution as a MATLAB graphical user interface. This was largely because, as Geomatics students, we've dealt with MATLAB in the past, so the programming language was very accessible. And in terms of the coding itself, the MATLAB app designer environment uses something called callback functions to specify the actions performed by elements, like editable text fields or drop-down bars. And these functions are then activated with the click of a button, and the data is saved as variables in the workspace. The first aspect of the app that we coded was the initialization tab. This segment can essentially be thought of as our landing page, and during its development, we asked ourselves two questions. One, when people open this application, what will they be greeted with? And two, what are the most important personal identifiers that we want to capture right away? In order to maintain the accountability and the transparency of field notes, we thought the most vital user inputs would be things like first name, last name, employer, email, and telephone number. From there, we thought, okay, now that we have this basic user data, what else do we need to establish a baseline understanding of the survey site? And the first thing that came to mind was atmospheric data. With physical field notes, surveyors read the data off of their total station and record it. But we thought we could streamline the notation process even further by using a simple drop-down bar, which would then reference a selected location and scrape the atmospheric data off of Environment Canada web pages, and these are updated quite frequently. The coding process for this functionality was quite challenging, as the drop-down bar had to be cross-referenced with a matrix that contained URLs. Then the URLs would be used to access web pages, which would then be scraped of HTML data that would be fed back into MATLAB and finally converted to text. This was eventually achieved by reaching out to the MATLAB community, which provided a great deal of technical advice. And interestingly enough, it aligned quite well with one of our initial goals of ensuring that the development process was open sourced. At that point, we said, okay, so now we have user data and atmospheric data. What additional information would help us understand the survey site? Field sketches. So we sought to embed freehand drawing capabilities into the app. We found that there were actually significant challenges with doing this in MATLAB because MATLAB itself doesn't have any functions or third-party plugins capable of freehand drawing. To make something like that happen would actually require someone to basically code from scratch an axis that tracks every single click of the cursor as it moves across the screen, and then to plot it later on. And this gets even more complicated when the choice of color selection is added. Now, believe me, we definitely tried to make this happen, but because it was outside of our technical know-how, we chose instead to emulate the sketching functionality through graph plotting. So what we currently have in place is an interface where people can plot specific elements like roads, trees, and sidewalks using representative linear and nonlinear functions. We strongly believe that enabling users to draft legible, in-depth sketches will be one of the most revolutionary developments in transitioning from physical to digital field notes. And we're currently working towards developing the functionality for people to be able to draw using either a finger or a stylus. Having input all the site-specific data, we thought the next logical step would be to allow users to input leveling and traversing data. At present, users have the choice of specifying between differential and precision leveling and between a closed or open traverse. In addition, users are able to perform very basic calculations, which helps to streamline the data entry process. And these calculations also provide the added benefit of allowing users to double-check their readings, effectively ensuring that all legs of their network are properly observed, instead of having to come back later on if a mistake is made, which is the current status quo. The final tab in the application takes all the data that's been input so far and presents it as a report with a standard format. We thought ensuring uniformity across all recorded digital field notes was important because it makes them readily understandable to subcontractors, which might be working on the same project but in different companies, and more broadly to professionals across the industry. Two additional features in this tab that we think are really cool are the automated date and timestamp and the auto-generated report number. To us, these were essential components for ensuring that entries remain tamper-proof and that the chain of ownership is properly documented. And overall, we were quite excited by the various functionalities that we were able to provide within this iteration of our application. We felt that at the end of the day, we were able to get our idea across and that we have a solid basis from which to continue developing the application. The next section will walk through the product testing portion of our development.
We tested the efficiency of the application using example datasets for leveling and traversing. First, I will talk about the data that we got for leveling dataset comparisons. You can see the results of that testing in these graphs. The graph on your left shows the time taken to enter and complete the real-time in-field data and calculations. In this graph, you can see the comparison between data entered using physical entry and the data entered using digital entry. On average, physical entry took 84 seconds to complete, and the digital entry was completed just in 20 seconds. Our applications overall resulted in 76% in time savings when comparing traditional pen and paper method to digital method. While the graph on your right shows the time taken to re-enter the same data for revisions through the traditional pen and paper method and also through our application. On average, for this type of data entry, our application resulted in 29% in time savings. We then performed the same tests for a traversing dataset. The results of this dataset are outlined in these graphs. For the in-field real-time calculations and data entry, you can see that the application allowed for up to 71% in time savings, while for the revisions, it allowed for up to 38% in time savings. As you can see, the time savings that can be achieved through use of an application can benefit the surveying profession substantially in terms of efficiency. And these time savings can in turn result in significant cost savings too. Using the data from our previous tests, we were able to approximate that we save 64 seconds for a leveling dataset in the field. Assuming we collect 25 sets per job, that makes the time saved per job to be 27 minutes. If we only complete 10 jobs per year with an assumed crew rate of $200 per hour, we can save up to $900 per year per crew. And this impact is approximated to result in $1,300 in savings per year per crew for traversing. As you can see, these results indicate that there are substantial advantages to developing an application in terms of cost savings in the surveying profession. Now I'm going to hand over to Alex to talk about our future work.
So to kind of finish this off in terms of our product, I'm going to talk about what we have and the future work that can kind of go with it. So to reiterate on our current development, we can break down the project into 4 components residing in 2 categories, a theoretical and a practical. The practical aspect consists of the program, which is an application that provides a uniform method of note-taking with emphasis on its organizational efficiency, and the website being a current means to distribute that application and give access to a public setting with any operating system. On the other hand, the theoretical aspect is comprised of the technical and legal outlines, one which aims to identify the functions and usages of the app, and the other that demonstrates a set of guidelines the app must abide by to ensure that information is legally applicable. Combined, this is DigiNote, a means to innovate the terrestrial survey field note standards by adapting the digitalized concept that is occurring globally. And so to finally sum this up, we asked ourselves, where can we take this from here? Well, creating a program version with mobile compatibility is a must. Having looked at current market app builders and their extensions, the transitions from desktop coding environments to field use tablets is easier than it ever has been. And this is the essential purpose of having retrievable field notes on the go. That being said, there needs to be an accompanying framework to protect the privately owned data that companies collect. In other words, something readily available for reuse, but privately accessible for recall. And so to have this mobility and data protection needs, it has to be paired with some form of cloud storage, a transmitting and receiving utility that distributes the data from a field to office setting as a fully finished documentation. These practices will be the foreground for a legal, technical, and revolutionary field note in the digital world today. That's all we have for today, and we're happy to answer any questions.